Now let's look at more questions in as far as stoichiometry revision is concerned. This question says 50 grams of butane, right? A butane is a hydrocarbon. It consists of carbon and hydrogen. So it is used as a fuel and then it burns completely, right? It burns completely in excess oxygen to produce carbon dioxide and water. So if the question says, if the statement says it burns completely, it means all the butane actually is used up in the reaction, meaning butane is our limiting reagent and then oxygen is in excess, because we are told that this combustion or this burning process takes place in excess oxygen to produce carbon dioxide and water. But just to put this context, into context, let's understand that most hydrocarbons are actually used as, fuels. They are a source of energy. What does that tell us? It tells us that when these fuels burn, the major product that we actually want to get from this fuel is energy. So this is typically an exothermic reaction, okay? So the carbon dioxide and water are actually the byproducts, okay? So because energy is not a chemical per se, would only include the byproducts in the reaction, right? And then the question says, calculate the volume of carbon dioxide, right? That will be produced at STP. What does STP stand for? It stands for standard temperature and pressure, right? Because this is a stoichiometric problem, it says that the law of conservation of mass must actually be applied. Now, let's ask ourselves the question, is the equation of reaction balanced or not? If not, then we need to do something about it. Okay, let's check carbon, okay? Carbon is 4 on the left, 1 on the right, okay? So then we need to do something. I'll be tempted to put a 4 there, okay? Then carbon is sorted. What about hydrogen? We've got 10 of hydrogen on the left and then 2. It means we'll need maybe a 5 there, okay? Then that leaves us with oxygen, right? Now, if you look at oxygen, on the left it's just 2, and then on the right we've got 4 times 2, which is 8, plus 5, which gives us 13, okay? But already, if it's 2 is to 13, and then this side will definitely need maybe a 13 over 2, okay? But remember, when we balance, we use integers or whole numbers. What does that say? We have to multiply everything by 2 so that we get rid of that denominator, which is the 2. So pay careful attention to that, right? So if we multiply everything by 2, we're left with 13 there, okay? Then we'll have 2 there. 4 times 2 here, we'll get 8. And then here we'll get 10, right? Now let's check if it is balanced indeed. Carbon, it's 8 on the left, 8 on the right. Hydrogen, 2 times 10, that gives us 20. We also have 20 on the right. Oxygen, we've got 13 times 2, which is 26. Now if you go to the right, it's actually 16 plus 10, which gives us 26. So the stoichiometric ratio in which these substances react to form the product during this combustion reaction. So this burning completely, it's combustion, right? So the term that refers to the burning of fuels in excess oxygen is called combustion. So the stoichiometric ratio is 2 is to 13 is to 8 is to 10, right? Now we want to know what is the volume of carbon dioxide that will be produced at STP. This is a multi-step type of a question, okay? So the first part of the multi-step was to balance, because the reaction equation for the reaction was not balanced. So we ask ourselves, how many moles are present in 50 grams of butane, right? So we know that moles of methane, so butane, which is C4H10, is actually equal to mass of sample over molar mass, all right? The sample is 50 grams divided by the molar mass of butane. So it's 12 times 4, all right? Which is 48 plus 10, which is 58, right? So just to verify that by means of a calculation. So carbon the mass of carbon is 12 multiplied by 4, right? Then we would add 10 for hydrogen, okay? Right? Plus 10, okay? that gives us a value of 58, right? That's 58 grams per mole, right? So if we calculate the moles that are present there, so it's going to be 50 divided by 58, okay? So in a 50 gram sample of butane, we've got 0.86 moles, right? So this is 0.86 mole, right? Okay, now we want the volume of carbon dioxide. So 2 moles of butane produce 8. So the ratio of butane to C4H10 to carbon dioxide is 2:8, right? So if we've got 0.86, okay, it will give us what? 4 times that. So if we're looking for 4 times that, it's going to be 4 multiplied by 0.86. Where am I getting the 4? Where are we getting the 4? If 2 produces 8, it means 1 will produce 4, okay? So that's, we get a decimal fraction of 3.44 moles, right? So this will produce 3.44 moles. Now we're asking ourselves that if the moles of carbon dioxide is equals to 3.44 moles, okay, what volume will be occupied by that number of moles of carbon dioxide? Okay, so what do we know? We know that a mole of any gas at standard temperature and pressure will actually occupy a fixed volume, which is the molar gas volume of 22.4, right? So we know that moles is equals to volume over molar gas volume, right? Now, for us to determine the volume of hydrogen gas, we'll then say 3.44 moles is equals to the volume that it will occupy divided by the molar gas volume, which is 22.4 cubic decimeters, right? So our volume is actually the product of the moles of carbon dioxide and the molar gas volume. So for us to get that, we can simply do our calculation, 3.44 multiplied by 22.4, which is a constant, right? Okay, this gives us a value of 77.06, right? 77.06 cubic decimeters, right? So that's the volume of carbon dioxide that will be formed. So what is important here is to recognize which aspect of the mole concept the question actually deals with. Thereafter, identify the correct formula, do the necessary substitution, but remember to convert the mass into mole. Why? Because the mole is the SI unit of quantity of matter. So this is typically your multi-step type of a problem. Hopefully that makes a lot of sense.